Welcome to Calculus Homework, a special worksheet on finding values of a, k, b, other variables that would make a function continuous. On that worksheet, the first one is number 17, and we want to find the values of k and m so that this function would be continuous on this interval. Okay. We know, first of all, that for that function to be continuous, the limit of this piece has to equal the limit of that piece there at x equals -2. So first of all, we know that the y value here, for it to be continuous, would have to equal the y value here at x equals -2. So I'm going to plug in -2 everywhere I see x. Simplifying, that'll be 4 plus 2k plus 3 is equal to 7. No, that isn't 7. That's -4 plus 3. That's 7 plus 2k equals to -1. Subtract our 7. We get 2k equal -8. Divide by 2, and we get k equals -4. All right. We also have to find the value of m, and that would involve these two pieces of the function. We know that if that's continuous, then the y value on this piece has to equal the y value on this piece here. And it looks like, okay, all this action is going to be happening at x equals 3. So everywhere I see x, I will plug in 3. And let's just go ahead and solve for m. That would be 6 minus 3. That's 3 equals 3 minus 2m. We subtract our 3. We get 0 equals -2m. Divide by -2. And we get m equal to 0. So those are the answers that we get for that one. Okay, let's look at number 6. We have this function. What two limits must be equal in order for the function to be continuous at -1? That would involve the limit of this piece. So the limit of 2 as x approaches -1 would have to be equal to the limit of mx plus k as x approaches -1. All right. Another way of saying that is 2 would have to equal to mx plus k. If we look at the next one, what two limits must be equal for it to be continuous at 3? That's going to involve these two pieces. The limit of mx plus k as x approaches 3 will have to equal to the limit of -2 as x approaches 3. Another way of saying that is that -2, got that here, would also have to be equal to mx plus k. All right, if we look at this first at the green one, okay, We notice once again those limits will be approaching -1. So in the green one, I'm going to plug in -1 for x. That'll give me 2 equal to -m plus k, because -1 times x, -1 times m is -m. And then if you look at the other one, that limit is approaching 3. So in this one here, we would let x be equal to 3. That gives us -2 is equal to 3m plus k. We have two equations, two variables, so we know we're going to be solving a system. It'll be this equation, that equation, and anytime you've got two equations and two variables, it's a system. I need to solve this, and I notice that I've got two positive k's here. If I temporarily make one of those k's negative, I'll be able to solve the system. I'm going to multiply the top equation by -1, both sides. So -1 times 2 is -2. -1 times a -m is positive m. -1 times positive k is -k. And then the other bottom equation, I'll just copy it down. And you remember from solving systems, we just combine now. -2 plus 2 makes -4. M plus 3m is 4m. And the k's cancel. We divide by 4. And that gives us m. -4 divided by 4 is -1. Now we need to find the value of k. So all we need to do is go back to one of these equations. And plug in what we just found out. I'm going to go with this black equation, which was 2 equals -m plus k. We just found out that m was equal to -1. So I'll plug in -1 for there, plus k. Opposite of a negative is a positive, so that gives us 2 equal 1 plus k. We subtract 1, and that gives us 1 equal to k. So we get -1 equals m, positive 1 equals k. All right, let's look at this one, number 7. Okay, but two limits, okay, must be equal. Okay, for the function to be continuous at x equals -2. First of all, we know the limit of kx squared plus m as x approaches -2 has to be equal to the limit of 4x plus 1 as x approaches -2. Okay, so we're going to end up having to find out where the y value of the first piece equals y value of the second piece at x approaches -2. Might as well go ahead and plug in -2 for x. Okay, so -2 squared is 4 times k, gives us 4k plus m. 4 times -2 is -8, plus 1 is -7. We also know that the limit of this piece as x approaches 3 has to be equal to the limit of that piece as x approaches 3. So we are going to end up having to solve. For x plus 1 equals to kx minus m. We know that we're going to need to plug in x equals 3. We can go ahead and do that. 4 times 3 is 7, plus 1 makes 8, equals 3k minus m. Or another way of saying it is 3k minus m equal to 8. Okay, this is nice. The equations are ready to combine. We don't have to multiply anything. We can go ahead and add the equations. That gives us 7m is equal to 1 divided by 7, and we get m equals 1/7. Now we go back and plug that into one of the equations. I'm going to use the red one. So that gives us 3k is equal to 8 and 1/7. I want to stop and just check my math for a second, because so that's going to be 8 times 7, 56 plus 1 is 57 sevenths divided by 3 over 1. Leave, change, flip. 3 will go into itself once. It'll go into 57 19 times. So we get 19 sevenths, or 7 goes in the 19 2 times with 5 left over. Since I got these strange fractions, I want to check one more time and make sure I did this one correct before I go any further. Let's see, we know that that was equal to that at x equal to -2. -2 squared was 4. 4 times -2, that's it. It's equal to -7. Then we know that 4x plus 1 was equal to kx minus m at x equals 3. Okay, 4 times 3 was 12, plus 1 makes 13. Ooh. Okay, so I have made a mistake right there. All right, that should be 13. So we have 4k plus m is equal to -7. Okay, that should be 13 is equal to 3k plus m. All right, I'm going to copy this slide and go to the next one and fix that. I apologize for the error. Okay, and my mistake, so that should be 13. That means that's 13. Okay, and so that gives us 6, so we get 6/7. Well, we still get a lot of crazy fractions. All right, so I'll come over to this one, and that'll be 6/7. That's going to leave us with 7 and 1/7, which is 57. Divided by 3. So 57 times 1/3, 50 over 21. Okay. Well, all right. Last one, thankfully. Okay, for what value does this limit not exist? Okay, and of course we know that that's x equal to 5, because if we were to do 2 times 5 plus 3 over 5 minus 5, that would give us 13 over 0, which does not exist. Okay, for what values of a does the limit of g of x as x approaches pi exist? Okay, so first of all, that means that we're going to have to solve this. And we can go ahead and plug in pi. On our unit circle, we know the cosine of pi is -1, so that's 3 times -1, which is -3, equals pi a plus 4. We subtract our 4. That gives us -7 equals pi a. I don't need that a there. Divide both sides by pi. So the answer is -7 over pi equals 2a. Okay. All right. We want to know, will this same value of a make the function continuous at x equals pi? Okay. And that answer is actually a common sense answer. If we look here, this function could never be continuous because this piece works all the way up till we get to x equals pi, skips over it, then this piece continues with x greater than or equal to pi. Okay, that means there is a hole at pi. So for this function, okay, it can never work because g of x is undefined at x equal pi. Okay. That concludes this homework on this worksheet. Thank you so much for working through it. Enjoy the rest of your evening.